In this video, we're going to solve applications involving the law of sines from 7.2. Let's go ahead and get started here. Let's consult the figure, and we want to find the length of the span of a proposed ski lift from A to B. We're really just looking at this triangle that's in blue here. The surveyor measures the angle DAB, which is measured as 25 degrees, and then walks 1,900 feet to a point C over here and measures the angle ACB to be 15 degrees. And we want to use that information to help us find side AB here in this triangle. So let's say angle A, angle B, angle C, side A, side B, side C. And we're interested in side C. That's what we want to find. So angle A is 180 minus 25 is 155. And then B is, we'll figure that out in just a second. C is 15 degrees. So 115 plus 15 is 170. 180 minus 170 is 10 degrees. Side A is not important to us. Side B is 1900. And we want to find side C. So let's use C is to sine of C as B is to sine of B. So side C equals 1900 sine of 15 degrees over sine of 10 degrees. 1900 sine of 15 degrees divided by sine of 10 degrees. And we get 2831.91 feet. All right. Let's go ahead and look at the next problem that tells us that we have two Coast Guard stations and that Able is due south of Baker and the distance between them is 270 miles. Then they receive an SOS signal so that the SOS is coming from north 55 degrees east for Able and south 60 degrees east for Baker. And that puts a point C out here where the ship is. And I think you can already tell from my drawing that the ship is going to be closer to Baker, but let's prove that with trigonometry. So 180 minus 60 minus 55. It's going to be 65 degrees here. So angle A, angle B, angle C. A was 55, B was 60, and C is 65. Side A, side B, side C. Side C is 270. A is going to be the side that is across from angle A, so it's actually going to be the distance from Baker to the ship. And B is going to be across from angle B, so it's going to be the distance from Able to the ship. So this is the distance from Baker, and this is the distance from Able. So they ask us first for the distance from Able, so let's find side B first. B is to sine of B as C is to sine of C. So B equals 270 sine of 60 over sine of 65 270 sine of 60 over sine of 65, and we get 257.99, rounds this to 258.00. And now we want A is to sine of 55 as 270 is to sine of 65. A equals 270 sine of 55 over sine of 65. 270 sine of 55 over sine of 65 is 244.04. We see that Baker is going to be closer. So we're going to send the helicopter from Baker. 244.04 divided by 200 miles per hour that the helicopter can fly. It's going to take 1.22 hours, but we aren't asked to give it in hours. We're asked to give it in minutes. So we're going to multiply by 60. And this is going to be 73.21 minutes. So we got our answer in hours multiplied by 60 minutes in an hour to get our answer in minutes. Let's move on to our last application problem here. And we're going to talk about a leaning tower. So a famous leaning tower was originally 184.5 feet high, a distance of 121 feet from the base of the tower. There's an angle of elevation that's measured to the top of the tower, and it's found to be 63 degrees. We want to find angle RPQ, this angle down here. To do that, we're going to have to find this angle up here, though. And we're also going to find the perpendicular distance here, this height that I just drew in blue. So let's go ahead and find angle R here first to help us find angle P. So let's use the law of sines that sine of angle R over 122 feet is the same as sine of 63 degrees over 184.5 feet. And we have 122 sine of 63 divided by 184.5 gives us a valid angle, second arc sine. That answer gives us the angle R is 36.1 degrees. And then now that we know angle R is 36.1, we can say 180 minus 36.1 minus 63 is going to give us the measure of angle P. So 180 minus 36.1 minus 63 gives us 80.9 degrees. And now we have this right triangle here. It's 80.9, like so. And H is here, and 184.5 is here. So let's say that sine of 80.9 is equal to h over 184.5. So h is 184.5 sine of 80.9. 184.5 times the sine of 80.9. I get 182.18 feet. 182.18. And that makes sense that that distance there is a little shorter than this diagonal distance because the shortest distance between 2 points is a straight line. So it should be a little shorter than this diagonal distance here. All right, that's it for this video, and we'll come back next time and talk about 7.3. See you for the next video.